All right, so this is Unit 2A, 2B test review answers and guide. So first of all, up top, it does talk about the 2CD. I forgot to take that off. My bad, guys. So there's no 2C or 2D on the actual test. It's just 2A, 2B. So let's get working on these problems. So number one, we have to isolate the absolute value. We have a multiplication here and a subtraction. So we do the opposite of the subtraction. So if there's addition or subtraction, do that first. So opposite operation. So SAD map instead of PEMDAS. Addition or subtraction first. Then multiplication, division. Now the absolute value is isolated. It equals a positive number, so we keep working these out. We're going to work it out into two equations. Negative 9 plus r equals 10. And negative 9 plus r equals negative 10. Because 10 and negative 10 are both the same distance from 0 on a number line. So we have to work both of these out, these equations. You add 9, r equals 19. That's a possible solution. And on the right side, add 9. R is going to equal negative 1. Do a quick check of these. You can do these in Desmos or by hand. You're checking for extraneous solutions. Be sure to check for extraneous solutions. These are solutions that mathematically we did all the work. They work out, but then when you substitute them back into the original problem, some reason they don't work. So we have negative 10 times 10 minus 5. Right side. So we have, that's negative 100 minus 5. That's looking pretty good. Negative 105 equals negative 105. Good. So 19 works. And let's check negative 1. Plus negative 1. Sorry about that. Minus 5 equals negative 105. Simplifying the left side. Absolute value of negative 10 is 10 times negative 10 is negative 100 minus 5. Oh, yeah, looking good here, too. Negative 105 equals negative 105. Awesome, that works. So we have two solutions for this problem. All right, let's look at number 2. Number 2, you have to isolate the absolute value, just as we did just before. This is divide by 9. That division is outside of the absolute value. So we need to move it with the opposite operation. Ooh, that's not right. 3 times 9 is 27. The absolute value equals a positive number, so now we can move on. Split it up into two problems. Negative x minus 4 equals negative 27 is also 27 away from 0. Solve both of these. 31. It's a negative 1. Divide by negative 1, you get negative 31. Over on the right side, so that's a possible solution. Let's get this other possible solution. Think of it as a negative 1 instead of negative x. Divide by negative 1. X equals positive 24. Let's do a quick check. Again, you can do this on Desmos in your head. I'm going to check negative 31 first. So the negative is on the outside of the x. So when you're substituting, make sure you have that negative out there. So this is the original. Opposite or negative, two negatives is a positive, or the opposite of negative 31 is a positive 31. You can think of it either way, it'll work. 31 minus 4 is 27. Absolute value of 27 is 27. Whoa. Whoa. 27 divided by 9 is 3, so that works. So negative 31 works. And check 24. Opposite of positive 24, negative 24. Negative 24 minus 4 is a negative 28. What did I just... Did I do something wrong? Oh, I did something wrong way back at the very beginning. That should be 23. Oh, man, I hope you guys are yelling at me. That should be 23. My bad. So that should be 23 inside. That would have been tragic. I noticed because 28 divided by 9 does not work out very nicely. And so that should be a negative 23. Nope, I totally goofed up. That should be a negative 27. Oh my goodness. And the absolute value of negative 27 is positive 27. Jeepers. 27 divided by 9. And does that equal 3? Yes, it does. So that's also a solution. So 23 is also a solution. Sorry for messing that up so bad. Number 3. Isolating the absolute value. You have a 1 here. You should subtract 1. It's a v minus 10 equals 44. Divide by a positive 2. Now, absolute value is isolated. It's a positive number, so we can break this up into 2 problems. Negative 3v minus 10 equals positive 22. And negative 3v minus 10 equals a negative 22. Solve both of these equations. Divide by negative 3. And we have a fraction, negative 32 over 3. Just going to have to leave it like that. Add 10 on the right side. Never cancel that other one out. Divide by negative 3. 2 negatives divide to a positive. So that one works out to a nice integer. The other one is a fraction, and that's okay. We're going to check both of these. I don't know where to check them. So I'll check it on the left side. 1 plus 2 times negative 3 times negative 3 over 3, 32 over 3, minus 10. See if that equals 45. 1 plus 2 is on the outside. That stays there. Negative 3 times negative 32 over 3. That simplifies out to negative, and the negative will become a positive. Again, doing this on Desmos might be easier. If you want to practice your math, then well, by all means do it. You can't do the 1 plus 2 yet. You can't do that because there's a multiplication. Absolute value of 22 is 22. I'm just going to put parentheses around that. You don't have to have parentheses. And 2 plus 22 is 44. 44 plus 1 is 45. So the right side equals the left side. Awesome. And we got to do this with 4. I'm just going to substitute it in up top here. So if I put 4 in there, and I'm just going to run through this. Negative 3 times 4 is negative 12. Minus 10 is negative 22. Absolute value of negative 22 is positive 22. 22 times 2 is 44. 44 plus 1 is 45. So that works out also. So both of them are answers. You can do it that way also. Doesn't matter to me. Number 4. All right, let's work on this problem. Absolute value is already isolated. It does not equal a positive or a negative number because we don't know what x is. So we're just going to proceed as if it's positive. So 2x plus 5 equals 3x plus 4. It's one of our possible solutions. And 2x plus 5 equals, we need to do the opposite. So you can put negative 1, and that's a binomial, so we need to change the term or signs of each term. So you could put negative 3x minus 4 if you wanted, and leave the negative 1 out. Either way, we just got to solve both of these. Get your like terms together. 2x is positive, minus 2x. 5 is positive, x plus 4, minus 4. Get your constants together. X equals 1. So that's one of our possible solutions. Next one, distribute in. We've got to get rid of that parenthesis before we can do any other kind of math. Now we get our like terms together. seeing a fraction. All right, well, we'll deal with it. So that's a possible solution also. Now we just need to check these. Again, you don't have to show me the check, but there are going to be extraneous solutions, so you always need to check. And I guarantee there's going to be one in here. So 2 times 1 plus 5 is 7. 3 times 1 plus 4 is 7. Absolute value of 7 is 7. That works. So 1's an answer. Now let's check the other solution. Oh, this one's not as friendly. But we'll get through it. Just a fraction. It's a number. It has feelings. So we can work with them. We have good brains, so let's use them. Multiply the numerators when you're multiplying fractions, so negative 18. Multiply the denominators. 1 times 5 is 5. Multiply the numerator on the right side. 3 times negative 9 is negative 27. 1 times 5 is 5. All right, next, we got to get like denominators because we're adding. So getting like denominators, so negative 18 fifths, we need 5 to become something over 5. So 1 times 5 is 5, so 5 times 5 is 25. That'll work. On the right side, I want to get like denominators there also. I want a denominator of 5 also, so we have like denominators. 4 times 5 is 20. So now we have like denominators on both sides. Cool. Now we are adding the fractions, so we have like denominators, so you add the numerators. 25 plus negative 18 is 7. 7 fifths. Wait a second, that's supposed to be 27. My goodness, I'm sorry, guys. Long day, I guess. Negative 7 fifths. Absolute value of 7 fifths is 7 fifths. And does that equal a negative 7 fifths? No. So that is an extraneous solution. So you just cross it out or say extraneous with that number. Either one. All right, next one. Choose all solutions that apply. First step, get the absolute value isolated. Divide by 4. When you divide by 4, the left side stays the same there. Simplify out the 4. We have 8x divided by 4 is 2x. 16 divided by 4 is 4. And we don't know if absolute value is isolated. We don't know if the right side is positive or negative, so we're just going to keep going as if it's positive. Because of that variable, the x, we don't know. 3 minus x equals, I put a negative 1. You can really just change the signs of each term in the binomial. And that would work also. So get my like terms together. Minus 4. Negative 1 equals 3x divided by 3. Get a fraction, negative 1/3. Possible solution. Other side, distribute that negative 1 in. Like I said, you could have just started with, you could have just changed the signs. So get my like terms together. The reason why I'm doing the way I'm doing it, the order I'm doing it, is because I like my x terms to be positive. So I kind of put a little thought into that before I just added the 2x versus adding x. It doesn't matter which way you go. But once you pick one way, then the x's are on the one side, the constants, you got to move to the other side, so then we can figure out what the actual x equals. Equals negative 7 and negative 1/3. So right now, you have a couple solutions here, and I think the last one is no solution. I don't know, it didn't come up on my paper for some reason. We got to check these. So let's check. So I have 4 times 3 minus, let's put in negative 1/3 right away. Let's rip this Band-Aid off and hope that, oh, that's supposed to be an absolute value, my bad. Maybe this will come out nicely. All right, we have, keep the 4 on the outside, do not ever distribute inside of absolute values. 3 minus and negative 1/3, we're gonna make we gotta subtract fractions, so we need like denominators. 3 over 1 is the same thing as 9 over 3. 8 over 1. 8 with the denominator 3 is 24 over 3. And 9 minus a negative becomes a plus. So that's 10 over 3. 24 times negative 1 is negative 24. And 3 times 3, I guess we didn't need to do that. It was multiplication. My bad. That's 9. That I didn't have to do that in the last step. Totally didn't have to do that. It should just be 8/3. It would simplify to. So that should simplify down to negative 8/3. My bad. Didn't have to do it. That's the right side with like denominators. Absolute value of 10/3 is 10/3. It's still multiplication. So we have to show some kind of multiplication. So 4 times in parentheses. Now we need like denominators. 16 over 1 what is that? 48 over 3 like denominator. On the left side, multiply them out, you get 40 over 3. Right side, add the numerators. Oh, works out. Okay, so negative 1/3 is an answer. But make sure you choose all solutions for this. So negative 7 could be an answer. So we need to check that. I know it's a lot of work. If you put this in Desmos, it's a little faster. It is faster. But if you enjoy substituting these in, do it. I'll always give you enough time in class to work these out. So put in negative 7. And 3 minus negative 7 is 3 plus 7, which is 10. I don't know why I keep doing that. That's supposed to be an absolute value. Negative 8 times negative 7 is negative 56 plus 16. 4 times the absolute value of 10 is 10. 56 and negative 56 minus 16 is a negative 40. That does not work. Not an answer. So the only answer is negative 1/3. All right, when you're working out number 6, working out errors, what I would do is I would absolutely solve the problem. Don't even look at the answers. Really hard to play teacher and see where students make errors. So I would solve this problem. On my own, and then then look back at the answers. So you should be adding 10 first. Order of operations. The only way to move negative 10 is to add 10. Now it equals a positive number, so we got to keep moving on. 10x plus 4. You notice I have not compared to what's over there on the work. You might be able to do that, but more times than not, people get things wrong when they don't. They just try to figure out the error without actually doing their own work. It's not easy to do. Divide by 10. You get x equals 5 over 10, which is 1/2. Oh my goodness, why am I writing it there? On the other problem, you subtract 4. Divide by 10. You get negative 13/10. Now I will actually take a look at the answers and see where they went wrong. So I'm just going to do a highlighting of, so the first part, what happened there? They did 10 plus 10. Is that what we did on this the first step? No, well, we added 10, but we didn't add the 10 plus 10 here. Oh my goodness, I just did it wrong. I wrote a negative 10. My bad. That's supposed to be a positive 10. But it actually doesn't change anything because that's where things went wrong. They did 10 plus 10. Order of operations, you can't do that. You got to do a subtract 10 first. So this should have been a subtract 10. Subtract 10, which is 70, which then is 7, which is 7 here. And then this is 3/10. So that should be 3/10. Reason why I'm going back here is I'm going to ask you also to solve the problem correctly. So -7 minus 4 is a -11. And so that's a -11/10. And you should check them, but they will work out, so that'll work. All right, moving on to... Oh, I didn't know there was another part. The following equation was incorrect. Determine which steps were wrong. All right, so it looks like I don't even want to look. So we have 5w plus 6 minus 2 equals 10. Well, that's minus 2, so you should add 2. 12 equals a positive number. 5w plus 6 equals 12. And you should also have 5w plus 6 equals -12. Sorry, I just don't have a lot of room here. Darn fractions all over the place. 6/5. More fractions. Let's look back. Where did they make the mistake? Well, it looks pretty quick. They must have said divide by -2 instead of add 2. And because of that, they've got a -5. It's correct that it'd be a no solution if it equaled -5, but it doesn't equal -5. It should equal 12. So that's where the mistake is. And then we have the work, and we could check it if we wanted. You could check it on Desmos, but that one didn't actually say correct it. All right, let's graph number 6. So now we're getting into inequalities. So this is 2b. Inequalities. So we have the absolute value is already isolated. It is not a negative number on the right side, so we can keep moving on. Make sure to follow your steps in your notes. 9x plus 3 is less than or equal to 21. And then the other inequality is 9x plus 3 is greater than or equal to -21. I'm jumping right into it, solving. 18 divided by 9, divided by 9. X is less than or equal to 2. And on the right side, I'm going to solve them both first. -24 divided by 9. Oh boy. -24 over 9 reduces down to -8 over 3. So what I do on a number line, I just look at -8 over 3. And I look at 2, which one's the smaller number. -8 over 3, I'm just going to put it somewhere in the number line. And 2 I'll put over on, because it's bigger, on the right side of the number line. Doesn't matter, like I'm not looking at the intervals. I'm just looking at the placement of those numbers. Now, let's actually dive into x is greater than, so numbers that are greater than or equal to -8/3. Equal to means it's a filled-in point. It's included. There's a point there. There's a dot. There's a coordinate there. Greater than are numbers to the right on a number line. X is less than or equal to 2. Equal to is filled in. Less than, smaller numbers. So they're shaded towards each other. This is an and statement. So I want to write it and. So you're going to write, you can write it two ways. You can go -8/3 is less than or equal to x, which is less than or equal to 2. Or you can write it as interval notation, -8/3, comma, 2. Either way is correct. Number 7, we need to isolate the absolute value, so add 6. At this point, the absolute value is isolated. We look, and it is not a negative number on the right side. It's a positive 13, so we're going to keep moving on. Keep solving. And the other answer is going to be 2x plus 3 is less than or equal to 14. So you remember to switch to inequality when you switch the sign of the number, the constant. We're solving each problem out. -3. Subtract 3. We divide it by a positive number, a +2, so we do not switch to inequality. All right, let's graph both of these. So I look at it again, I'm looking at the number, which one is smaller, -8 or 5. -8 is, so on the number line, I'm going to put -8 somewhere on the left. And as you go to the right, you get bigger numbers, so 5, put it over on the right somewhere. I'm not worried about intervals and what numbers in between, just need to know where those numbers are on the number line. Graphing them. 5 equal to, there's an equal to here, so fill it in. That's a point that's actual coordinate on the graph. And greater than or equal to greater than is to the right, bigger numbers. Now let's work on 8, -8. -8 is equal to again, so we're going to fill it in. It's a coordinate. It's equal to, meaning there's a point there. And then less than to the left. So these things are shaded away from each other. So for this, you could write x is greater than or equal to 5, or, this is an or graph when they're shaded away from each other, x is less than or equal to -8. So you can write it like this. Or you can write it, x is greater than 5, or equal to 5, and numbers that are greater than 5 is to infinity. Union, x is less, numbers that are less than -8 is -infinity to -8. Either way, it doesn't matter to me which way you write it. Moving on, number 8. So let's isolate the absolute value, so divide by -2. We're dividing by a negative, so we need to switch the inequality. And now we have the absolute values isolated. And look at this. First time, the right side of the constant is, the opposite side of the absolute value is negative. So now we got to contemplate, is it no solution or infinite solutions? So again, the question you got to ask yourself, the left side is, remember absolute value is always going to come out a positive number, is a positive number less than, because that's a less than symbol, -11. That's the question you need to ask yourself. Is a positive number less than -11? No. There's no possible way that's going to happen. So this is a no solution. You can also look back at the notes. There's special cases, and I have them written down. Less than is always a no solution. Greater than is always an infinite solutions. All right, let's look at number 11. Or number 9. I don't know why I said 11. Isolating the absolute value, should add 6 first. Divide by 4. We divide by a positive, so inequality doesn't switch. At this point, the right side, the absolute value is isolated. The right side is a positive force, so we keep solving. Switch the inequality when you switch the sign. Solve the problem. X is less than 2. The other inequality is x is greater than -2/3. So on the number line, which number is smaller, -2/3 or 2? Well, -2/3 is, so I'm just going to put that on the left side, and 2 somewhere on the right, because it's bigger. Let's start with x is less than 2. Less than means it's an open circle, meaning that there's not an actual point there. But the reason why you put a circle there is to say that every number that is less than 2. So any number that's smaller than that, and there's really no other way to write it. So then like 1.9999999 would be represented. So where this open circle just means that that's not an actual point there, but every number to the left, less than it, will work. And then we have negative 2/3. That's not an actual point there, but greater than means every number to the right of negative 2/3 will work. Well, these are shaded towards each other. Towards each other, you can either write them as inequalities, always less than signs when you write smallest to biggest, smallest number to biggest number, or you could write it, they're not equal to, so there's going to be parentheses to 2. All right, number 10. Let's see, we have add 11. So it starts out, it kind of looks like it's going to be a special case. Let's see if it actually turns out that way. Negative 28. Oh, divide by negative 3. Divide by negative 3. We divided by a negative, so that inequality needs to switch. So it becomes greater than. Did I do it again? I did it again. That should be negative 27. I should probably quit for today. 9 now, so it's a positive number, so now it's not a special case. So we got to break this up into 2 problems. Negative n minus 5 is greater than 9, and negative n minus 5 is less than negative 9. Do not ever switch the inequalities what's inside, or the signs of inside the absolute value. Never do that. The reason why you do the right side is because you're accounting for the positive and negative distance from that number with the absolute value. Think of it as a negative 1. Divided by negative 1 switches the inequality. So we have a n is less than negative 14, and divide by negative 1, so we need to switch the inequality. N is greater than 4. So now I'm just going to draw, I don't have a number line here in front of me. So I'm going to draw negative 14 is on the left side of the number line. 4 is on the right side from each other. And let's kind of do a quick little, n is less than negative 14. So not filled in, less than to the left. N is greater than 4, not a filled in circle. Number is bigger than 4, greater than to the right. This is an or problem. So you can write it like n is less than negative 14 or n is greater than 4. Or you can write this as intervals. So think about numbers less than negative 14, or you can think of the number line here. That goes to negative infinity to negative 14, not filled in. Union together with 4 is not filled in, so that's a parenthesis, and it goes to the right forever to infinity. So either way you can write this. And that's it. That's the review. Please come to my office hours if you have any questions.